All right, welcome back. So we're going to go over questions 61 through 80 of the AWS Machine Learning Associate Exam walkthrough. Question 61. But before we go, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate Exam. Question 61. A financial services company needs to comply with regulations requiring all ML model predictions to be explainable. The company uses SageMaker to deploy models for loan approval decisions. Which solution will provide model explainability for regulatory compliance? SageMaker Debugger, SageMaker Clarify, SageMaker Model Monitor, or AWS CloudTrail? B, SageMaker Clarify. It's designed for model explainability and fairness. It generates SHAP, this is Shapley additive explanations, values. These values show feature contributions. It provides prediction level explanations required for regulatory compliance. It supports both online and offline explainability. It integrates bias detection and fairness metrics, and it meets requirements for GDPR, ECOA, and other financial regulations. So, explainability features. Feature importance for each prediction, SHAP value attribution, bias and fairness reports, regulatory compliance documentation. Why are the other answers wrong? Debugger. That's for training issues, not prediction explainability. Model monitor. That is for drift detection, not explainability. CloudTrail. That's for logging APIs, not predictions. 62. A company is building a computer vision model to classify product defects. The company has 10,000 labeled images, but needs to improve model performance. The images have significant class imbalance, 95% non-defective, 5% defective. Which technique will best address the class imbalance? Random undersampling, SMOTE, class weights, collect more images. Answer is C. So class weights penalize misclassification of minority class during training. It preserves all original data, both defective and non-defective. It's simple to implement in most machine learning frameworks. It's effective for severe imbalance like that 95.5. There's no data loss, unlike undersampling, and there's no synthetic data artifacts, unlike SMOTE for images. So you can see the class weighting formula below. All right, and why are the other answers wrong? Undersampling, this loses the valuable majority class data, so those 9,500 images. And SMOTE is designed for tabular data and can create unrealistic synthetic images. And collecting more, well, this is time consuming and not feasible. So that operational overhead. Question 63. An engineer needs to train a model on sensitive healthcare data. The data must remain encrypted during training and must not be accessible to plain text to anyone, including AWS personnel. What solution would meet these requirements? SageMaker with server-side KMS, SageMaker training in VPC mode, encrypting data client-side before uploading to S3, using SageMaker with Nitro enclaves for confidential computing. So, Nitro enclaves. This provides an isolated compute environment. Data processed in encrypted memory and accessible to operators and AWS. There's attestations that ensure only authorized code is processes data. It meets the strictest confidential computing requirements, HIPAA and compliance ready for sensitive healthcare data, and data is never accessible in plain text outside of Enclave. So Nitro Enclave security includes isolated CPU and memory, cryptographic attestation, no persistent storage, and no interactive access. So why are the other options incorrect? So KMS encryption is for data decrypted during processing when accessible in memory. VPC and EBS, this is data accessible during training in plain text memory. Client-side encryption, it's still decrypted during training. 64. A company wants to reduce ML training costs. The company has training jobs that run for 35 hours each week over the next 55 weeks. The jobs can tolerate interruptions. What solution will minimize costs? Spot instances, manage spot training, reserve instances, opt in the SageMaker savings plan with a 1-year term, and make all upfront payment. So D, the predictable workload of 35 hours a week for 55 weeks equals consistent usage. So SageMaker savings plan provides up to 64% discount for committed usage. A 1-year term matches the 55-week requirement, and all upfront payment maximizes the discount. Compute optimized instances work best for training workloads, and the best TCO or total cost of ownership is there for predictable schedules. So the cost comparison, you see on demand is $10,000, spot would be $3,000, but there's interruptions. Savings plan would be $3,600, no interruptions. Why are the other answers incorrect? Well, spot can be interrupted. This is risky for scheduled, regular 35-hour jobs. Reserved instances don't apply to SageMaker training jobs. Next question. 65. A company needs to run ML model training jobs on SageMaker for 35 hours a week over the next 55 weeks. This is just repeat. That's weird. Okay. Okay. Sorry about that. 66. A company has a manufacturing inspection application that detects product defects. The company trains quality assurance robots by using images from a digital camera. The application produces quality images of 1200 by 1200 pixels. The company must automate model training to serve the images to the robots. Which data format will meet these requirements? Parquet, Record IO, Augmented Manifest, TF Record. So, augmented manifest. This is the format is optimized for SageMaker image training with metadata. It efficiently handles image references and labels in single JSON lines files. It has native integration with SageMaker ground truth labeling. It supports efficient data loading without conversion. It references images in S3 with associated labels. It's best for automated training pipelines with labeled images. So you can see below the JSON with the labeled manifest, the source ref in the class, how that would work. Why are the other options incorrect? So Parquet is for tabular data, not for images. Record IO is a legacy format. It requires conversion overhead. And TF Record, that's TensorFlow. So it's less flexible than augmented manifest. Next question. 66. A data scientist is working on a fraud detection model. The model will be used in production to make real-time decisions. The data scientist wants to ensure the model performs well on the minority class for fraudulent transactions. Which evaluation metric should the data scientist prioritize? Accuracy, precision, recall, or F1 score? C. So recall. Recall measures the ability to identify all fraudulent transactions. It's critical for fraud detection. So missing fraud, the false negatives, is costly. The formula is recall TP divided by TP plus FN. So you can see this is a high recall, ensures minimal fraudulent transactions go undetected, and it's important that false positives are there rather than losing the false negatives. So the fraud detection priority, missing fraud equals manage your financial loss. A false alarm means a manual review, which is acceptable. So you want to maximize your recall to know what those fraudulent detectives are. Are the other options wrong? Accuracy. So this is misleading with a class imbalance, right? 99% legitimate equals 99% accuracy, doing nothing. Precision, this focuses on false positives, not catching all fraud. F1 score, this balances precision and recall, but recall should be prioritized. All right. Question 68. An ML engineer is deploying a model to production and needs to ensure high availability across multiple AWS regions. The model artifacts are stored in S3. Which deployment strategy provides the most resilient solution? Deploy the model to a single SageMaker endpoint, use cross-region replication and deploy endpoints in multiple regions, deploy the model to ECS with auto-scaling, use global accelerator with a single region SageMaker endpoint. B. So, cross-region replication ensures model artifacts are available in multiple regions. Multi-region endpoints provide true high availability and disaster recovery. Route 53 health checks enable automatic failover between regions. It protects against regional failures and the lowest latency by routing to the nearest healthy region. So you can see the architecture would be the S3 to and the SageMaker endpoint with the cross-region replication. You see region 2 has S3 with the SageMaker endpoint, and you have a Route 53 health check for a failover between them. So why are the other options wrong? The single region, there's no protection against regional failure. ECS is still single region deployment. And Global Accelerator improves network performance, but doesn't provide regional redundancy. Question 69. Company is using SageMaker to train a sentiment analysis model. The training data contains customer reviews with very long text sequences, up to 10,000 words, and training is taking too long. What should the engineer do to reduce training time while maintaining model quality? Truncate sequences to a maximum of 512 tokens, use gradient accumulation with smaller batches, switch to distributed training with multiple instances, and reduce the learning rate and train for more epochs. C. So distributed training splits the work across multiple instances. It parallelizes computation for faster training. It maintains the model quality with proper synchronization. It scales linearly with numbers of instances for large sequences, and it handles long sequences without truncating data. SageMaker supports distributed training out of the box. So the distributed training has benefits such as the 4 instances means 4 times faster training. There's no data loss from truncation, and this is better for long sequences. So why are the other options wrong? So truncating loses important information from the long reviews and can reduce the quality. Gradient accumulation can help with memory, but doesn't reduce the training time. Reducing the learning rate can increase the training time, which is the opposite of the goal. Question 70. An engineer needs to process streaming data from IoT sensors for real-time anomaly detection. The data arrives at variable rates, sometimes with sudden spikes. Which service combination is best suited for this use case? Kinesis data streams, Lambda, SageMaker endpoint, SQS batch, SageMaker batch transformation, S3 glue, SageMaker processing, DynamoDB streams, step functions, SageMaker endpoint. A. So Kinesis data streams handles high throughput streaming data with variable rates. Lambda can process records in real time with automatic scaling. SageMaker endpoint can provide low latency anomaly detection inference and handles spikes with automatic scaling. And there's end-to-end real-time processing pipelines. So you can see the architecture is the IoT sensors, 2 Kinesis, 2 Lambda, 2 SageMaker, 2 alerts. So why are the other options wrong? So SQS and batch, this is batch processing, not real time. S3 and glue, again, batch processing, not streaming. DynamoDB streams, this is for databases, not sensor data. So know your use case and you'll be able to work backwards from there. Question 71. A company deployed an ML model to a SageMaker endpoint. The ML engineer needs to explain to company stakeholders how the model makes predictions. Which solution will provide an explanation for the model's predictions? SageMaker Model Monitor, SageMaker Clarify, distribution of inferences from A/B testing and CloudWatch, add a shadow endpoint, analyze prediction differences on samples. SageMaker Clarify. This is purpose-built for model explainability. It generates SHAP values showing feature contributions to predictions. It provides both global and local explanations. It works with deployed endpoints for online explainability, creates visualizations stakeholders can understand, and meets regulatory requirements for explainable AI. What are the features? Feature importance rankings, SHAP value attributions, partial dependence plots, bias and fairness metrics. Why are the other answers incorrect? Model Monitor monitors data model drift, not explainability. A/B testing distribution shows performance comparisons, not prediction reasoning. And shadow endpoint is for testing variance, not explaining predictions. 72. An engineer is using SageMaker to train a deep learning model that requires distributed training. After some training attempts, the engineer observes the instances are not performing as expected. The engineer identifies communication overhead between the training instances. What should the engineer do to minimize the communication overhead between the instances? Put the instances in the same VPC, store the data in different regions from where the instances are deployed. Or place the instances in the same VPC, but in a different AZ, store the data in a different region from where the instances are deployed. Place the instances in the same VPC subnet, store the data in the same region and availability zone where the instances are deployed. Place the instances in the same VPC subnet, store the data in the same AWS region, but in a different availability zone from where the instances are deployed. C. So the same subnet minimizes network latency between instances. The same region in AZ minimizes data transfer latency. It reduces cross-AZ and cross-region data transfer costs, the lowest network overhead for distributed training, the fastest instance-to-instance communication, and it's optimal for gradient synchronization and distributed training. So you see the network latency hierarchy from lowest to highest would be same AZ, same subnet, would be microseconds. Same region, different AZ, single digit milliseconds. Different regions, tens to hundreds of milliseconds. So why are the other options wrong? Different region data. This means high latency accessing training data. Different AZs. This means increased latency and data transfer costs. So, question 73. A company's trained multiple versions of a model. The company needs to deploy all versions simultaneously and gradually shift traffic from the old version to the new version while monitoring performance. Which SageMaker feature should the company use? Multi-model endpoints, multivariant endpoints, shadow deployments, A/B testing with weighted traffic. Multivariant endpoints. So these host multiple model versions on the same endpoint. It supports weighted traffic distribution. So a 90% old, 10% new. There's gradual traffic shifting like canary deployment. There's real-time performance comparisons. This can monitor metrics per variant. There's production grade with automatic rollback capabilities. And you can see the configuration here with some Python here showing the variant name with the variant weight for the old model at 0.9 and the new model at 0.1. So that's at 90-10 split. So why are the other options wrong? Multi-model is for hosting mini models efficiently, not gradual rollout. Shadow is for testing only and doesn't serve production traffic. And then A/B testing is not a specific SageMaker feature. It's a variant endpoints enable this. 74. An engineer needs to retrain a model weekly using new data. The retraining process should be fully automated, including data validation, training, evaluation, and deployment. Which service should orchestrate this workflow? Step functions, SageMaker pipelines, Glue, or EventBridge with Lambda. SageMaker pipelines is purpose-built for machine learning workflow orchestration. There's native integration with all SageMaker services, built-in steps for data processing, training, evaluation, and deployment. Model registry is integrated for versioning. It supports conditional execution based on model performance, and it's the MLOps best practices built in. So what are the steps? Data validation, feature processing, model training, model evaluation, conditional deployment, if the metrics meet the threshold, and model registration. So why are the other options wrong? So step functions is for general workflow orchestration, and it's more custom than what this is for. Glue workflows are for ETL, extract, transform, load. This is not for end-to-end machine learning workflows. EventBridge and Lambda is custom code, too much operational overhead. So a company is training a recommendation model using collaborative filtering. The company has millions of users and millions of items. The training data is extremely sparse. Which algorithm is most suitable for this scenario? XGBoost, k-nearest neighbors, factorization machines, linear learner. Factorization machines. This excels with sparse, high-dimensional data. So it's designed specifically for recommendation systems, and it captures feature interactions efficiently. It handles millions of users and items, and it works well with implicit feedback data. And it has a lower memory footprint than matrix factorization for large data sets. So factorization machines benefits include it learns feature interactions automatically. It's effective with sparse user item matrices. It's scalable to millions of users and items. And SageMaker it's a SageMaker built-in algorithm. Why the other answer is incorrect? So XGBoost is for tabular data, not optimized for collaborative filtering. K-nearest neighbor doesn't scale well to millions of users per item or items. And linear learner doesn't capture feature interactions needed for recommendations. 76. An engineer trained a model that performs well during validation, but poorly in production. An investigation reveals the production data has different statistical properties than training data. What's the likely cause of this? Overfitting, data drift, insufficient data, or learning rate is too high. B. So different statistical properties indicate data drift. Training data no longer represents production distribution, and model assumptions are violated by changed data patterns. A common cause of production performance degradation, so it has to be retrained, So the validation was on similar distribution to training, so the model appeared fine, but it didn't execute well in production. So data-driven examples include the customer behavior changes, seasonal patterns, market conditions evolve, or new product categories are introduced. Why are the other options wrong? Overfitting would show poor validation performance. It wouldn't work in the beginning. Insufficient data would also show poor validation performance. A higher learning rate would be a training issue, not a production deployment issue. 77. A company trained a model using min-max normalization on the training data. The company is now deploying the model for production inference. How should the company handle normalization for production data? Calculate a new set of min-max normalization statistics, reuse the same min-max normalization statistics, calculate a new min-max from a batch of production samples. All right. Calculate a new set of min-max from each production sample. Use these. B. So training and inference must use identical normalization parameters. This must prevent distribution shift caused by a different scaling. It'll maintain the model's learned feature representations and a standard machine learning best practice for pre-processing consistency. The normalization parameters are part of the model pipeline. So with this rule, the training statistics equals the inference statistics. Otherwise, the model sees different feature scales, which means it'll have poor predictions. So why are the other options incorrect? A, C, and D. The new statistics. This creates a data distribution mismatch between training and inference and leads to dramatically reduced, training and inference, right? It leads to dramatically decreased model performance, and it breaks the assumption that training and production data have similar distributions. 78. The company is planning to use SageMaker to make classification ratings that are based on images. The company has 6 terabytes of training data that's stored on FSX for NetApp ONTAP system virtual machines. The SVM is in the same VPC as SageMaker. An engineer must make the training data accessible for ML models that are in the SageMaker environment. What solution will meet these requirements? Mount FSX file system as a volume to the SageMaker. Create an S3 bucket. Use a mount point for S3 to link the S3 to FSX for ONTAP. Create a catalog connection from SageMaker Data Wrangler to FSX for ONTAP. Create a direct connection from SageMaker Data Wrangler to FSX for ONTAP. A. So FSX for ONTAP supports NFS or SMB protocol mounting. SageMaker training instances can mount FSX file systems directly. The same VPC enables low latency and high throughput access. There's no data copying required, and you can access 6 terabytes in place. It's cost effective, so there's no data transfer charges within the VPC. There's native integration between FSX and SageMaker. So the architecture would be FSX for ONTAP, which can do 6 terabytes of data with an NFS or SMB mount, and then goes towards the SageMaker training. One of the other options are wrong. So the mount point for S3, linking S3 to a file system, not FSX to SageMaker. So it's a different use case altogether, and different tooling altogether. So Data Wrangler. So Data Wrangler is for data exploration, not training data access. 79. A company has a machine learning pipeline that's triggered when new training data arrives in an S3 bucket. The pipeline pre-processes data, trains a model, and deploys it. Which solution will trigger the pipeline with the least operational overhead? Create an S3 lifecycle rule to transfer data to SageMaker training. Create a Lambda function that scans the S3, programming the Lambda to initiate the pipeline. Create an EventBridge rule that has an event pattern that matches the S3. Or use managed workflows for Apache Airflow to orchestrate the pipeline when new data is uploaded. So C, EventBridge. EventBridge natively integrates with S3 events. Those file or management events, right? It's simple event-driven architecture. There's no custom code required, so no operational overhead. There's automatic triggering on S3 object creation. There's direct pipeline invocation, and there's minimal operational overhead, like I just said. So the event-driven architecture would be you upload something to S3, an EventBridge rule sees it and kicks it into the SageMaker pipeline. Why are the other options wrong? So lifecycle rules don't trigger pipelines. Those are for data management, for transitioning or expiring objects. So it's more storage rather than something effective with events. Lambda scanning is custom code and logic, and polling logic specifically. So that would take too much time, too much code, too much operational overhead. MWAA is over-engineering. This requires too many other pieces, so airflow infrastructure also has to be constructed. And question 80. An engineer is developing a fraud detection model by using SageMaker XGBoost. The model classifies transactions as either fraudulent or legitimate. During testing, the model excels at identifying fraud in the training dataset. However, the model is inefficient at identifying fraud in new and unseen transactions. What should the engineer do to improve the fraud detection for new transactions? Increase the learning rate, remove some irrelevant features from the training dataset, increase the max depth hyperparameter, reduce the max depth hyperparameter. Model overfitting. So reduce that. Okay. So it's excellent on training, but poor on new data. So reducing the max depth makes a simpler, less complex tree. This prevents the model from memorizing training data, improves generalization to unseen transactions, has classic regularization techniques for tree-based models. So the overfitting pattern would show training accuracy at 99%, and then test accuracy would be at 65%. So the solution would be reduce that model complexity so it would see newer information. Why are the other options incorrect? Increasing the learning rate would actually worsen overfitting. Removing features might help, but not the primary issue for overfitting. And increasing the max depth would actually increase the overfitting further. So that is all for this section. We're going to stop here. Before we go, hit the like button, subscribe, and share this with anyone you know taking the AWS machine learning exam. We'll see you next time for questions 81 through 100. Have a good day.